Welcome to one more Flip Classroom math video. 3 tips before you start. First, you can slow down or speed up the playback if that helps you watch the video at your own pace. Second, you could pause the video any time to jot down notes. Third, you could turn on the captions and watch my words go by on the bottom of your screen. This lesson mainly focuses on how to use a normal distribution to estimate probability without the calculator. Now there's only certain problems that you can answer without the calculator, and I'm going to show you the territory first and then we'll do some problems. So check this out. Here's my normal distribution, just like before. And here's my mu, my average, my mean. Okay, so all normal distributions have the following properties. 68.3% of the data is within a standard deviation of the mean. So minus sigma or plus sigma, whatever these values are, 68% of the data is going to lie within one standard deviation of the mean. You know this. This is true for a normal distribution. It's one of the properties or attributes of the normal distribution. Similarly, if you're 2 standard deviations away from the mean, so that would be minus 2 sigmas this way or plus 2 sigmas that way, then that data percentage goes up to 95.5%. So 95.5% of the data in a normal distribution is 2 standard deviations away from the mean. When I say away from the mean, I mean either negative 2 standard deviations or positive 2 standard deviations. Finally, the last one we're going to pay any attention to, and you'll see why, 3 standard deviations away from the mean goes up to 99.7% of the data. So that means that almost all of the data is within 3 standard deviations of the mean. So you can see from this number that 0.3% of the data is more than 3 standard deviations away from the mean. So this is just a map of the territory. So this is the kind of thing, and it's not in your formula booklet if you're an IB student. You just have to remember these key numbers. Questions that are like this will fall on a no calculator portion of oh no, never mind. You guys have calculators for your entire test. So this is a quicker way to do some of those probabilities. So let's do some. Okay, our first problem, I'm going to keep it straightforward, then we'll increase the complexity. So here we go. Here's our normal our normal distribution with a mu, an average of 20, and a variance of 25. Notice how I don't have that squared. So sigma is 5. So standard deviation is 5 because it's the square root of 25. Okay, so now we're set. Here is our question. Find the probability that random variable x is between 15 and 25. And here's my first prompt. Sketch the distribution with shading. Now I'm aware that in my class you have the calculator everywhere, so you can do some of these calculations without sketching a graph. But you might see a prompt that says sketch the graph and shade the area. So do that. Sketch the graph and shade the area. Okay, here's my graph. There is my average, and 1 standard deviation away is 15 and 25, and that indeed is what this is about, because my standard deviation is 5, so to the left my value is 25, that's 1 standard deviation, and to the right it's 25, to the left it's 15 because it's the mean minus a standard deviation. So I marked on my axis my 25 and my 15, and then I shaded my area. So that's the area under the curve. Now what is the probability that random variable x will fall between 15 and 25? Pause the video, write that down because that's all you got to do, and come back. Super simple. 68.5% of the data falls inside 1 standard deviation away from the mean. So this is right off of that last board with the standard deviations all spelled out and the percentage of the data spelled out. So this is our warm-up on this. This would be on the test or quiz. This would be an easy low-hanging fruit question. X, random variable, part of a normal distribution with a mean of 20 and a variance of 25. Find the probability that x is less than 15. My prompt here is sketch the distribution and shade the area under the curve that represents that probability. Okay, so there's a sketch of my normal distribution. My mean, my mu, is 20, and then 1 standard deviation, 2 standard deviations to the left, and 1 standard deviation, 2 standard deviations to the right. Now what I want you to do is shade the area that represents this probability. Okay, less than 15. Here's 15, less than 15. It's this area that represents the probability that random variable x is under 15. Now, here's the prompt. Knowing what you know from the last board, tell me what this probability is. Let me hint you along a little bit. The probability that random variable x is greater than 25, that's half our data. So we know this part of the curve is 1/2. Now we know that the part that's 1 standard deviation away, that's from here to here, is 68.3% of the data. So now you can use these two numbers to find out what that area, what that probability is. Okay, so you probably figured this out from how I was talking about this. It's going to be easier to figure out the probability of this, and the rest of it and subtract that from 1 to find this. So what I did is I set us up here. 1 minus the sum of 0.5, that's all of that. Now if this is 68.5, then this is going to be half of 68.5. Because remember, the curve is symmetrical. So this area is going to equal that area. So I did 0.5 minus 0.683 over 2, put those together, subtract them from 1, and I get 0.159 or 15.9% chance that random variable x is below 15. Okay, I think this one might be a little tougher, and I changed my prompt here. Well, not quite, but I'm going to explain it to you a little differently. Here we go, sketch, then find probability. Now, a test question could be written to sketch the probability distribution, shade the required area, and then show how the sketch finds the probability. So you really would have to be able to do the things we're doing here on the board. When you were done, you could pull out your calculator and test it with that function in your calculator just to make sure you were right. But that prompt could require that you use this way of finding a probability. So don't just blow this off and use your calculator. You need to be able to do it on the board or on your paper. So pause the video and do the sketch. Okay, here's our sketch. Pretty straightforward. I just went ahead and labeled it 2 standard deviations away from the mean. So we know we're 20, 15, and 10. That's 2 standard deviations. And then 25 and 30, that's also 2 standard deviations. Here is my calculation prompt. Random variable x greater than or equal to 10. So I shaded everything greater than or equal to 10. Okay, pause the video and find that probability. Okay, so check this out. This one requires a little bit of formulating. First off, when you look at the graph, really all you need to do is figure out what this is and subtract it from 1. That would be one way. In fact, there's other ways to do this, but this is the way I chose. So whatever that is, subtract it from 1 and you're home free. So here's my calculation. 1 minus, now this expression up here is 1 minus 95.5. So that's the whole thing minus the part that's within 2. See, this is 2 standard deviations. So this bit here is 95.5, right to there. Okay? So the parts on the outside that we're interested in are 1 minus that. But we have to divide it by 2 because half of that stuff is here, which we want to count. The other half is here, and this is what we're trying to find. So 1 minus 95.955 divided by 2 is going to give us 97.8% chance of random variable x being greater than 10. One more problem. This time we're going to get decimally. It's a little messy, but not too bad. So here's our scenario. Random variable x normally distributed with a mean of 4.6 and a sigma, standard deviation, of 1/2. So first thing, just sketch that distribution before we start looking at this problem. So go ahead and make a sketch. Okay, here's my normal curve. I put my mean right at the peak, and then I went 1 standard deviation each way, so adding 1/2 and subtracting 1/2, and then adding 1 and subtracting 1. So I've written a normal distribution sketch that's certainly going to help us answer this question. So now, shade the region that you need to calculate and do that calculation and come right back. Okay, greater than 6 is this little area there. Now, here's what I noticed is that I've got 95.5% of my data is in here. So that means that 1 minus 95.5 is what's left for these two tail ends. So that's what I wrote here, 1 minus 0.955. And then that number is going to be divided by 2 because part of that is here and an equal part of that is there. So I've got to divide that by 2 and I get 0.025 as my probability that random variable x is going to be greater than 5.6. What is the probability that random variable x is greater than 3.6 but less than 5.1? So pause the video, shade your diagram. I cleaned mine up a little bit. It's still a little messy, but I cleaned it up for this. So go ahead and shade your diagram and come back. Okay, so greater than 3.6, less than 5.1. That's this area there. Now, I want you to calculate what that area is, or calculate the probability, use the diagram, and come back. Okay, I did this a little differently from the last one, so I just marked my probabilities on my diagram here, and let me go over that. So this segment, from one below to the mean, that is half of 95.5, because 95.5 would encompass 2 standard deviations away. But this piece right here, just that part there, that's half of 95.5. So the probability of this part is 0.955 over 2. And similarly with this one is half of 1 standard deviation away. And so 1 standard deviation away is this green shading right there. This is all 68.5% of the data. So that piece is 0.685 over 2. The total probability is just going to be the sum of those areas. So I went ahead and added them up here, and I get 0.819 or 81.9% chance that random variable x falls between 3.6 and 5.1. Now that you've watched the video, take a moment to jot down any remaining questions so you can bring them to our next class. You can also watch the video again if you need to deepen your understanding. If you enjoyed the experience, please click like or subscribe.